This is ACT practice test or ACT test B04. Wasn't a practice test when it was originally given, but now it's used as a practice test. And I'm doing question 51 through 60, answering them. There are two sections of Algebra 1 taught at high school. The average score on the final exam for the 20 students in the first section was 74. The average score on the final exam for the 25 students in the second section was 92. What was the average of the final exam scores of all the students, or of students in Algebra 1? Remember, average is sum divided by number of numbers equals average. So if I can find the sum of all the students, divide by the number of students, which 20 and 25, divide by 45, I'll get the average. Well, for the first group, it was an average of 20 students. So sum of that number divided by 20, or sum of scores, equals 74. Well, the sum is 74 times 20. You can do that on a calculator. 740, that's 1480. And then for the second group, it was the sum divided by 25 equals 92. And again, the sum will be 92 times 25. Put that in a calculator. What do you get? 920, 1840 plus 460 equals 2300. So all the students together had a sum of 1480 plus 2300. I'm doing it without a calculator, but it's a calculator test. 3780, and then divide that by 45. And I think that is 8 times 5 is 40, 32, 36. So it's 80 something, the 70s are out, and it will come to 80, oh, and the 90s are out too, so it's either 83 or 84, and it comes out to, let's see, gosh, 8 times 5 is 40, 36, 180, that's 4, so it's 84. I did it without a calculator. You can use a calculator, of course. So now this says, number 52, the table below gives some statistics based on the points Veronica earned on each of her first 3 math exams. There's 3 math exams. The median is 80. It says the range is 11, but it gives the maximum, which is 90. If the range is 11, the median is the middle number. So I knew that was 80. It says it. The range is the highest minus the lowest. The maximum one is given 90. 90 minus 11 is 79. That's a very terrible 79. And then it says if it can be determined what is the mean. Well, 79 plus 80 plus 90, 170 plus 79, 249 divided by 3. 3 times 8 is 24. 3 times 3 is 9. The answer is H. A club has 30 members. The position of president, vice president, and treasurer will be assigned to 3 distinct members. Which of the following expression gives the maximum number of distinct assignments that can be made? Well, for the first assignment, there's 30 choices. And then one of them is already president, let's say, and it says they have to be distinct, different people. So the second position, what is that one? Vice president only has 29 choices. And then the third position, because now one is chosen for president, one vice president, only has 28 choices, and that is answer C. Jane and Margaret moved to New City at the same time several years ago and have lived there ever since. Jane has lived there half of her life, and Margaret has lived there 3/5 of her life. And it said they moved there at the same time. So 1/2 of Jane's life equals 3/5 of Margaret's life. If J represents Jane's present age, okay, well, that's what I wrote, J. Which of the following expression represents Margaret's present age? Well, I will solve this in terms of m. Get Margaret m by itself. I will multiply both sides by 5/3. The 3/5 cancel out. That's 5/6 j equals Margaret 5/6 j. That's answer H. When 7 to the 126th power is multiplied out, what is the digit in the ones place? Well, 7 to the first power is 7, then 49, and then 7 to the third power, 28 and 6. Oh, gosh. 63, 7 times 4 is 28, and 6 is 34. And then times 7. You can do this on a calculator. I'm doing it without 7 for 30. 2401. And then this is going to end with 7 again. So there's 1, 2, 3, 4 places, and then it will repeat again. And so I would divide by 4. 4 divided by 4 is 1, remainder 0. This would be remainder 1, remainder 2, remainder 3. This would be remainder 0. So 126 divided by 4, it repeats 4 times, 3, 4 is 12, and then I carry down the 6, 4 goes into, 4 times 1 is 4, and there, I can't do any more, so the remainder is 2, the remainder is 2, it ends in a 9. Shown below is a quadrilateral ABCD inscribed in an ellipse. The figure will be placed in the standard XY coordinate plane, and the ellipse will be described by the equation x squared over 9 plus y minus 5 squared over 16 equals 1. Given that AC is the minor axis and BD is the major axis, AC is the short axis, shown right there in the image. BD is the long axis. What will be the coordinates of point A and B? Well, it's x minus h squared over a squared plus y minus k squared over b squared equals 1. That's the equation of an ellipse with the center hk. So the center of this ellipse is 0. Nothing is subtracted from x, and 5. So 0, 5 is the center. And then it shows that on the x side, a squared is 9, so a is 3. So it would go 3 to the left and 3 to the right. Well, 3 to the left of 0, 5 is negative 3, 5. So point A is negative 3, 5. It's either J or K. And then B squared is 16, so B is 4. So it goes up and down, 4 from the center. Up from 4 from 0, 5 is 0, 9. So 0, 9 would be B, and that's J. And in fact, only one of them has 0, 9 as point B, so that would have decided it, but how would I know that when I'm starting? There are 90 equally spaced dots marked in a circle. Shannon chooses an integer n. Beginning at some randomly chosen dot, Shannon goes around the circle clockwise and colors in every nth dot. He continues going around and around the circle, coloring in every nth dot, counting each dot, whether it is colored in or not, until he has colored in every dot. Which of the following could have been Shannon's integer n? Well, the test literally has you going around in circles. Oh boy. One way to do this would be to list out the numbers, or to, start with 3 and go 3, 6, 9, 12, and see if you end up every number from all 90 dots. And you can do that with 3, 4, 5, 6, 7. If you recognize that, well, recognize two things. If you have an even number, you are always going to, like, let's say B4, D6, and you start at an odd number dot. You start at dot 1. You're always going to hit odd dots. At 1, 1 plus 4 is 5, 5 plus 4 is 9. Or if you start at an even number, 2 plus 4 is 6, 6 plus 4 is 10. In other words, if you start at odd, you're always going to hit odd numbers. If you start at an even number, dot, you're always going to hit even numbers. So the even numbers are out. 4 is out. 6 is out. And then if you have factors of 90, you're always going to just keep hitting the same dots. So 3 is out. 5 is also a factor of 90, and that leaves only E7. But how would you, what if you didn't think about that? Well, try, again, you could list them all out and check 3, 6, 9, 12, 4, 8, 12, 16, and just keep going until you saw that you were hitting the same dot every time. Or you can try to make a simpler example. I'm going to make an example when I have 6. 1, 2, 3, 4, 5, 6, and I'll just number them. There it is, 6. And I will try 2, 3, 4, 5. And so let me start here, and I'll go every second dot. 1, 2, 1, 2, 1, 2. Uh-oh, I got back to the same dot. So notice I was only hitting odd numbers. That may have given it away, but also I eventually got to the same dot, and 2 is a factor. It goes evenly into 6, so that's out. Let me try number 3. I'll start at the same one again. I'll start here. 1, 2, 3. 1, 2, 3. Uh-oh. 1, 2, 3. I keep going. 1, 2, 3. Back to the same ones. So 3 is out. Also notice, 3 is out. And I was hitting even and odd numbers. Again, that may give me a clue that if I use an even number, I'm going to be in trouble. All right, now 4 and 5. 6 is not divisible by 4. 6 is not divisible by 5. Let me start here and do every fourth. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Uh-oh, I got back to the same one. But notice also I was only hitting even numbers because I started in an even. And if I started at an odd, I'll put a little z there. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I get back to the same number again, but I was always hitting odd numbers. So again, that tells me it can't be even. And then 5, boy, I've got to put something big there. I'll start here with 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I got all of them. So even numbers only always, if I started at an even number dot, I only got even number dots. If I started an odd number dot, I only got odd number dots. And also those I could see repeated the same ones. And 3, which is a factor of 6. So factors are out and even numbers are out. In this case, it eliminates 6. It eliminates 3. 4 is an even number. 5 is a factor of 90. 7 is neither even nor a factor of 90. So that's in there. But again, you could have just listed them all out. It would take a little bit of time. Maybe save it for the end, and then try it. 3, 6, 9, 12, 4, 8, 12, 16, 20, 24, etc. And you'd see with all but 7, you'd get to the same number. All right, next one. There are 100 file folders, each 0.45 inches thick, that will be placed in drawers. Each drawer can hold file folders with a combined thickness of no more than 7.5 inches. No folder is split between 2 drawers. All but one drawer, what is the combined thickness? Well, let's see. They're 0.45 inches thick, and each can hold 7.5. So 7.5 divided by 4.5. I'm not doing that one in my head. I did this right here. 16.67. Well, I can't have partial, so each one can hold 16 drawers. So I've got 16 file folders. Well, there are 100, so 100 divided by 16 is 6 times 6 is 6. 96. It says they got to hold full folders, and there's 4 left over. So I've got, the reason I couldn't do 16.67, it says no folder is split between 2 drawers. So I can only do whole numbers. That's where 16 came in. 7.5 divided by 4.5, just the whole number. 100 divided by 16 is 6. So I filled 6 drawers, and then there's 4 folders left over. Well, 7 not divided by 4.5, divided by 0.45. That's 16. All right, so 4 times 0.45, that's what's left. 1.8. What's the combined thicknesses of inches of the remaining folders? 1.8 inches. 4 folders left over times 0.45 inches. Which of the following expressions is equivalent to the sum? Well, one way to do this would be to put in some number for x, check it in the original expression, and check it in each one of those expressions. I'm not sure how long that would take because these are, not simple expressions. So I will try to simplify these. This is 3 over x plus 3 times x minus 3. X squared minus 9 is a difference of 2 squareds. X squared minus 3 squared. And then this is plus 6 over, and I need factors of negative 18 that add to 3. 6 times 3, and the 3 would be negative. So this is x plus 6 and x minus 3. Now that means that the common denominator is going to be every factor. X plus 3, x minus 3, and x plus 6. And just to make sure nothing cancels, the one that's missing here is x plus 6. So this is 3 times x plus 6 plus 6. The only factor missing here is x plus 3 times x plus 3. Just making sure 3x plus 18 plus 6x plus 18 is 9x plus 36. 9 times x plus 4. So that's the numerator. Nothing is going to cancel. That won't cancel with any of those. So that has to be the denominator, and only E has all 3 of them. Oh, wait a minute. This one does too, I think. X minus 3, x plus 3, x plus 6. Okay, so good thing I did this. 9x plus 36 is the numerator, which is E. But the denominator could have eliminated 2, but then again, I don't know what cancels out. So for all positive x and y, x to the 1/3 and y to the 5/4. Well, if I want to put them both into a root, I'm going to need the same denominator. The denominator is the root, the numerator is the power. So it's just like adding fractions. I want the same denominator. The denominator will be 12. 3 goes into 12/4, so this is x to the 4/12 times y. 4 goes into 12/3, 15/12. So that's like writing the 12th root. The denominator is the root, and then the power, x to the 4th, y to the 15th. Well, this is y times itself 15 times, and if I get 12 of them, I can pull it out of the root. So 15 minus 12 is 3, and then I put a y over here because I pulled it out. Y, 12 y's, y times y times y, 12 y's, but it's the 12th root. I can pull it out, and then it becomes 1y. So, or y to the first power. So this is y times the 12th root of x to the 4th, y to the 3rd, which is answer. No, let me Mr. Camera zoom. J. So that is B04, 51 through 60. I would think that of all of these, this one, 57, is the one that could take the most calculation, except when you realize when there is something that looks like an impossible sequence, just start working it out. And sometimes if you can make a smaller version of that sequence and see what's going on, then it will help you with the bigger. But even on this one, you could list 3, 6, 9, 12, boop, 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 boop. And you'll see you'll get to 90, and then you'll get to 3 again, 6. So you'd see this one will never hit new numbers. You could list them all out, and you'd get the answers E7. I just think that would take a little bit of time. That is all for this one.